let's just briefly look at the rectangular and polar coordinate systems now, and just to make sure we're familiar with how they work. There are two ways of representing the position of a coordinate in space. So here is our coordinate in space. Let's pick two coordinates. We talk about these quadrants as being quadrant 1, because that's the one we most often use, where both x and y are positive. 2, 3, 4. So going round counterclockwise. So quadrants 1, 2, 3, 4. And the same for the other coordinate system as well, quadrants 1, 2, 3, 4. If we look at the Cartesian coordinate system first, or the rectangular coordinate system, that's this one here, rectangular, and I want to say what the position of a coordinate is, say that position there, then I'm going to have to quote two numbers. How far have I gone along the x-axis, and how far have I gone along the y-axis, and that will give me my coordinates. We know, don't we, this is negative over here, so these are negative x-coordinates, these are negative y-coordinates. So I might have a coordinate something like, looking from this sketch, about -2, -3 would be the coordinate for that, wouldn't it? So that's how I would say where that position was in the, and we're very familiar with that, I think, the rectangular or Cartesian coordinate system. This one maybe not quite so familiar with, but I'm sure that you will remember it when we talk about it. First of all, what we do to get our position here of this coordinate is, instead of giving an x and a y coordinate and saying where it is, what we do is we say how far away are we from a particular point, the origin, and what's my angle relative to some sort of arbitrary position. So this is what's used in bearings in navigation. I'll measure my angles from north, and I'll measure my distances from a particular place. The reference point in the polar coordinate system we're going to use is the positive x-axis. So all angles are measured from there in a anti-clockwise direction. So to give a position, I measure an angle and a distance. So I would talk about an distance r and an angle theta for my position. So this might be a distance of, say, 4, and an angle 90, looks as though it's 90, about 45, about 135 degrees, something like that. Two ways of representing a position: rectangular or polar. It's just a way of saying where something is in 2 dimensions.